Hi, we're Team Think Outside the Rat Box. I'm Brittany.
I'm Katie.
Yeah.
I'm John Blake.
As a brief reminder, the goal of our team's project is to assemble and program an indirect calorimetry device that can be placed on top of a standard rat cage in order to assist with diabetes and obesity research in partnership with the Herman Van Horn Research Lab at ASU. Having ordered all necessary components for our indirect calorimetry box before leaving for winter break, our team has hit the ground running this semester. In order to have the possibility of testing with rats, the device we are building requires additional approval from IACUC. As a result, we are accelerating our timeline with a goal of finishing the device in February to allow time for a lengthier approval and testing process. Each team member has contributed based on their strengths, and together we have made significant progress. This semester, I have worked extensively with the operation of our CO2 sensors. This has included communicating with the sensor company, testing code in Arduino, and further understanding the calibration process necessary for accurate readings over time. Currently, the CO2 sensors are operating successfully with its analog pin connected to the Arduino. Further, I have begun making clear circuit diagrams and documentation for the Herman Van Horn lab so that they can better understand the electronics involved.
As the person responsible for the majority of our software development, I have spent a lot of time working to get usable data from the oxygen and carbon dioxide sensors. This process has included extensive research into serial communication, different Arduino communication protocols, and finally the integration of these premises with the Python programming language. I was eventually able to make my own advancements on an existing Python package in Arduino Sketch to meet our needs, and we are now able to pipe data from all 4 sensors used in the device into Python. I have also written Python functions that will send the necessary alerts about power failure or low oxygen levels to ensure rat safety. The next steps are 1, to establish how data will be output to the user, and 2, to develop a GUI to make it simple for users not familiar with programming to use our device to run experiments.
During the assembly process, John Blake and I have been mainly focusing on the design of the lid itself. In order to function properly, there needs to be an airtight seal where the lid connects to the box, as well as at the inlet and outlet holes and through the connections to the sensors. In order to make this seal, we've used weather stripping, silicone paste, surgical tubing, and brass fittings. In addition, because the safety of the animals is a top priority of the Herman Van Horn lab, we've included multiple safety features in our design to make it as safe as possible. This includes the oxygen pump being connected to the wall power through an external battery. So in the event of a power failure, the pump will continue to operate via battery. Through testing, I've determined that the external battery functions and will power the oxygen pump for around 20 hours, which would give ample time for lab representatives to stop the experiment.
Since the last video, I've been working on 3D modeling different boxes and containers to house all of our hardware and circuitry. One challenge that I've encountered in this process is designing airtight boxes to house our sensors and designing the containers to accommodate the tubing that directs airflow and also the wires for the circuitry. Through a rapid prototyping process, I've been able to successfully 3D print boxes for all of our major components. Going forward, we may need to redesign these boxes in order to improve aesthetics or even change the material that the boxes are made out of. Our goal is to have the indirect calorimetry box complete by February 19th so that the lab can get the necessary approval for animal testing. The main tasks that must be completed include the construction of the lid, as well as writing the program to process the information from the sensors. Thank you for your attention.